In this video, we are going to go over the Junior Certificate Ordinary Level Mathematics Exam, Paper 1, from 2015. Question 1, Part A, find the value of each of the following. Part 1 is 2.5 minus 1.5 multiplied by 0.1. Now, from our order of operations rule, our PEMDAS rule, we know that multiplication comes before subtraction. So we're going to have 2.5 minus whatever this evaluates to be. So that's going to be 2.5 minus 1.5 multiplied by 0.1, which is equal to 0.15. 0.15. So then 2.5 minus 0.15 is going to be equal to 2.35. Part 2, we're asked to evaluate the square root of 5 plus 1.25. So again, from our PEMDAS rule, we know that the first thing we want to do is the square root, but we can't do that until after we've added these two things together, because they're both under the square root. So if the square root was only over one of these two terms, then we'd do the square root first, but because it's over both of them, we have to evaluate this sum first, and then take the square root of whatever is left over. So this is equal to the square root of 5 plus 1.25, which will be 6.25, and the square root of 6.25 will be equal to 2.5. Part 3, minus 2 to the power of 3. So that's going to be equal to minus 2 multiplied by minus 2 multiplied by minus 2. So minus 2 by minus 2 by minus 2. There are 3 of them, that's why it's to the power of 3. So this is all multiplication, so it doesn't matter what order we do it in. So we can start off by multiplying the first two terms and leaving the third one alone. So minus 2 multiplied by minus 2 is 4. And that's multiplied by the other minus 2 that we still have left over. So minus 2 times minus 2 is plus 4. And this minus 2 stays where it is. Now 4 multiplied by minus 2 is going to be equal to minus 8. Part B says show each of the following numbers on a number line. So we're given a number line, and we're given 3 numbers, 0.1, a half, and 1.7. And we have to show where they are on the number line. So the first one is going to be 0.1. Well, that's going to be very close to 0. It's going to be less than 0.5, so it's going to be somewhere in here. So this interval is divided into 1, 2, 3, 4, 5 parts. So it'll be 0.1, 0.2, 0.3, 0.4, and 0.5. So 0.1 is going to be here. Next number we're given is a half. And in decimal notation, that's equal to 0.5. So that's already on the number line. That's this point right here. 1 half. Because 1 divided by 2 is 0.5. So a half is equal to 0.5. The third number we're given is 1.7. So that's going to be greater than 1.5 and less than 2. We know that each box subdivides it into an interval of 0.1. So it's going to be 1.5, 1.6, 1.7, 1.8, 1.9, and 2. So 1.7 is going to be here. Part C says shade in 1/3 of the following strip. So there are 1, 2, 3, 4, 5, 6 parts. So 1/3 of 6 will be 2. 6 divided by 3 is equal to 2. So 1/3 of 6 is 2. So to shade in 1/3 of the 6 squares, we want to shade in 2 out of the 6. So you shaded in 2 and left 4 unshaded. So we've got this third is shaded, this third, and this third is not. C part 2 says fill in the 2 blanks below to show 2 fractions that have the same value as 1/3. So it gives us 1/3. We have to show that that is equal to something over 6 and also 4 over something. So when we have a fraction, it keeps the same value as long as whatever we do on top, we do on the bottom. So whatever we multiply the numerator by, we also have to multiply the denominator by. So what that means is, here we have 6 on the bottom, so to go from 3 to 6, we have to multiply 3 by 2. So then we have to do the same thing on top to keep the fraction with the same value. So we multiplied 3 by 2 to get 6, so we multiply 1 by 2 to get whatever's on top here. So 1 by 2 will be equal to 2. So we have 1/3 is equal to 2/6, which is what we have up above. 1, 2, 3, 4, 5, 6. 1/3 is 2 of the 6ths. Then we want to do the same thing here. So we started with 1/3. The top is multiplied by 4 to get the top over here. So the bottom has to also be multiplied by 4 to keep it the same value. 1 multiplied by 4 is 4. 3 multiplied by 4 will be 12. So 1/3 will be equal to 4/12. Question 2. On the Venn diagram below, shade in the region that represents A intersection B. So we're asked to shade in the region that represents A intersection B. So they give us this symbol that looks like a lowercase n, and that means intersection. So that means the bit that's in both A and in B. So we're given 2 sets, set A and a set B, and we're asked to shade in A intersection B. So we're going to shade in the bit that's in both of them. So this part is in both A and B. So it's A intersection B. Next, we're told on the Venn diagram below, shade in the region that represents A union B. So this time, they give us this lowercase u symbol. That means union. That means everything that's in A or B. So every part of A or B. So if we're given the set A and the set B, then everything that's in either of them will be everything within the circles. So we're going to have everything shaded in. So that's this section, and the bit in between them are all shaded in. Part C says on the Venn diagram below, shade in the region that represents A union B without A intersection B. So they use this backslash symbol, that means without. So everything that's in A union B without everything that's in A intersection B. So from the first part, we showed this is A intersection B. From the second part, we saw this was A union B. So if we have this, and we don't count this bit in the middle, then we're going to end up with 2 outside circles, but not the intersection shaded in. So we have this part, and this part. But the bit in the middle will not be shaded in. Part D says put a tick in the correct box to show which of the following represents the elements that are in A but are not in B. So what this says is, what is this notation for A without B? So this says B without A, the elements of B that aren't in A. This says A plus B, that's not what we're looking for. This says A without B, so that is what we're looking for. So we want to put a tick under A without B. So the elements of A without the elements of B. Question 3. Daniel wants to buy a bike. The usual price of the bike is €320. The bike is on special offer in 3 different shops. In shop A, we're offered 10% off the usual price of the bike. So now we're asked to calculate the special offer price of the bike in shop A. So the first thing we want to do is to calculate 10% of 320, because it's going to have 10% off. So first we need to know what the 10% is. So 10%, I'm going to write this as a fraction instead of a percentage, is 1 over 10. So 10% is equal to 10 over 100, 10% per 100. And 10 out of 100 is equal to 1 over 10. So that's where this fraction is coming from. So 10% of 320. So of just means multiply. 10% of 320, that's 320 multiplied by 1 over 10, which is the same as 320 divided by 10. So that's equal to 32. So we're going to have 10% off, so we're going to have 320 minus 10%, which is 32. So that's going to be 320 minus 32, which is 288 euros. So there's your answer to part A. Shop B offers 1/4 of the usual price of the bike. Find the special offer price in shop B. So now we want to find 1/4 of 320. Because shop B gives us 1/4 off, so we have to find 1/4 of 320, so we know how much to get off. So 1/4 of 320, so 1 over 4 multiplied by 320 is equal to 80. So we have 1/4 off, we have 320 minus 1/4 of 320, which is 80. So that's 320 minus 80, which is equal to 240 euros. So there's your answer to part B. In shop C, we can pay 60 euros now and 20 euros at the end of each month for the next 12 months. Find the special offer price in shop C. So in shop C, the price is going to be 60 euros plus 20 euros 12 times. So we've got to pay 20 euros each month for 12 months. So we'll pay 20 euros 12 times. So 20 times 12. We're also going to have this 60 that you have to pay at the beginning. So that's going to be equal to 60 plus 20 times 12 is 240. That's going to be equal to 300 euros. So the special offer price in shop C is 300 euros. Part D says, do you think we should buy the bike in shop A, B, or C? And we have to give a reason for our answer. So the answer is we should buy the bike in shop B because the price is the lowest in shop B. So our answer is shop B. The reason is because the price is the lowest in shop B. So is our answer and our reason. Question 4. For her birthday, Rachel went to Belfast with her family. They left Dublin at 2:50 p.m. and arrived in Belfast 2 hours and 20 minutes later. At what time did they arrive in Belfast? So they left at 2:50, and they traveled for 2 hours and 20 minutes. So at what time did they arrive? So 2 hours on from 2 o'clock is going to be 4 o'clock. Then 20 minutes on, 50 minutes, is going to be 1 hour and 10 minutes. So it's going to be 5 o'clock and 10 minutes. So it will be 5:10 p.m. So 10 past 5 in the evening. The hotel room cost £140 sterling. The exchange rate is £1 sterling is equal to 1.28 euros. Find the cost of the hotel room in euros. So we're told that £1 is equal to €1.28. So this is just like any old equation. We're going to change what's on the left hand side into 140 because that's the amount it cost in sterling. So to do that, we've got to multiply the left hand side by 140. So we have 1, we want 140, so if we multiply 1 by 140, we'll get what we're looking for on the left hand side. So we'll have 140 on the left hand side is equal to 140 multiplied by 128 on the right hand side, because whatever we do on the left hand side we have to do on the right hand side because it's an equation. So we multiply the left by 140 to go from 1 to 140, so we also multiply the right by 140 to find out what the equivalent value in euros is. So 140 multiplied by 1.28 equal to 179.2 euros. 179.2 euros, so 179 euros and 20 cents is how much the hotel room will cost in euros. The family then went to a concert in Belfast. An adult's ticket costs 80 euros and a child's ticket 60 euros. Write the cost of a child's ticket as a percentage of the cost of an adult's ticket. So, a child's ticket costs 60 and an adult's ticket costs 80. So 60 out of 80, there's your fraction that shows your ratio of the two together. So to get into a percent, we need to change the denominator, whatever's on the bottom of the fraction, into 100. And then whatever's on the top will be per 100, so percent. So the first thing we can do is we can simplify this fraction a little bit. So we can divide the top and bottom by 10 to get 6 over 8. Then we can divide the top and bottom by 2 to get 3 over 4. And then we can multiply the top and bottom by 25. And the reason we're choosing 25 is because 4 times 25 is 100, and we want 100 on the bottom. So we're multiplying the top by 25. 3 times 25 is 75. And the bottom by 25 is 4 times 25 is 100. So that's what we're looking for. 75 out of 100 is equal to 75%. Percent just means per 100. So this is 75 out of 100. This is 75 per 100, or 75%. So we started with the fraction. That's just a ratio of the two numbers. And then we simplified the fraction all the way down, and then multiplied the bottom by whatever was necessary, in this case 25, to make it into 100. And then whatever's on the top, that's the percentage. Part D, there were 4,000 people at the concert. The ratio of children to adults at the concert was 3 to 5. Find the number of children at the concert. Okay, so the ratio of children to adults was 3 to 5. So that means out of every 8 people, 3 of them were children and 5 of them were adults. There are 4,000 people at the concert, So let's divide that into how many groups of 8 people there were, because we know how to divide up 8. We know if there's 8 people, then there's 3 children and 5 adults. So we're going to add these together to get 8. That's where the 8 comes from. And then we can divide the 4,000 people in the concert into groups of 8, because we know how to divide up 8 people. So we have 4,000 people in the concert. We're going to divide that into groups of 8. So 4,000 divided by 8 is going to be equal to 500. So there are 500 groups of 8. So in each one of those groups, 3 of those people will be children. So there will be 3 times 500 children, because there are 500 groups, and in each group there are 3 children. So it would be 1,500 children. Question 5. The set S is shown in the Venn diagram below. It has 5 elements. So it has 5 elements: A, B, C, D, and E are all in the set S. Some students were asked to write down subsets of S that have 3 elements. Owen writes down the subset A, C, D. Write down 2 more subsets of S that have 3 elements each. So all we have to do is choose 2 groups of 3 elements out of these 5. So for instance, our first subset could be A, B, C. There's a subset with 3 elements because A and B and C are all in the group. A second subset could be C, D, E. C, D, E. Because C and D and E are all in the set. These are not the only 2 subsets you could choose. You could choose any combination of 3 of these elements. So you could pick B, C, D, or A, D, E, or C, D, E, or any combination of 3 of these elements. Now, we're given a set A, B, W, and we're told to explain why this is not a subset of S. The reason why this set, A, B, W, is not a subset of S is because W is not an element of S. So we've got this Greek letter epsilon, that means is an element, and we've got a line through it to say that it's not an element. So W is not in the set S. So A, B, W is not a subset of S because W is not an element of S. So W is not in S, so ABW can't be a subset of S. Question 6. A juice bar makes smoothies in 2 sizes, small and large. Their menu is shown below. So we have the menu here. We've got various different types of smoothies, prices of the small smoothies, and the prices of the large smoothies. So we want to buy a small lemon crush and a large apple swirl. And we want to find the total cost of these 2 smoothies. So the small lemon crush, that costs €2.10. And the large apple swirl will cost €3.60. Plus 3.60. So when we add these 2 together, we'll get the total cost. So we have 2.1 plus 3.6, and that's equal to 5.7. So the total cost would be €5.70. Next, Elaine wants to buy 2 small smoothies and 1 large smoothie, and she has €7 in total to spend. So we want to complete the sentence to show the combination of smoothies that she can buy and find the total cost of those 3 smoothies. So we're given that she has to buy a strawberry slurp, a small one, so that'll cost €2. So that means she has €5 left over to spend on whatever we have here. We have a small smoothie and a large smoothie, and has to be affordable with €7, which we've taken €2 from, so €5. So for starters, we know that we can't pick a large strawberry slurp again because that would cost €4. And we've only got 5, so if we spend 4 on this drink, we'll only have 1 left to spend on this drink. But each of these cost more than 1, so it can't be a large strawberry slurp. It also, for the same reason, can't be a large lemon crush, because if we spend $4.20 of our €5, that only leaves 80 cents to spend on this small drink, and each of these cost more than 80 cents. Now let's take a look. Can it be a large apple swirl? Well, if it's a large apple swirl, that will cost $3.60, so it leaves us with $1.40. And all of the small drinks cost more than that, so it can't be a large apple swirl. That means all we're left with is a large banana boost. So if we buy a large banana boost, that will cost €3, and we'll have €2 left over. So we can also buy a small strawberry slurp, a small banana boost, or a small apple swirl. So let's choose a small apple swirl so that she has 1 of each. So we're given that it's a small strawberry slurp. The next one is a small apple swirl. And then the last one will be a large banana boost. Now we want to find the total cost of these 3 smoothies. So we have a small apple swirl costs $1.80. A small strawberry slurp costs €2. And a large banana boost costs €3. So if we add those together, we'll get €6.80. So that is the cost of the 3 smoothies. The juice bar makes another smoothie, an orange twist. A small orange twist costs $1.60. Use the prices in the menu to work out how much a large orange twist costs. So they're asking us to see what is the relationship between the small price and the large price. And what we see here is every time the large price is exactly twice as much as the small price. So if the small price is €2, the large price is 4. If the small is 1.50, the large is 2 times 1.50, which is 3. If the small price is 1.80, the large price is 2 times that, which is 3.60. And if the small price is 2.10, then the large price will be 4.20. So using the same relationship, if we're given 1.60 is the price of the small, costs 1.60, and the large will cost 2 times 1.60, and 2 times 1.6 is equal to 3.2. So that's €3.20. So that right there is the price of the large orange twist. Question 7. Graph the following inequality on the number line below. The inequality we're given is x is less than or equal to 2, and x is an element of the real numbers. So OR just means the real numbers. That means all of the numbers on the number line. So, given a number line, we're going to have 0 in the middle here. We're going to have 1, 2, 3, 4 going out that way, -1, -2, -3. So -3, -2, -1, 0, 1, 2, 3, and 4. And we're asked to graph this inequality on the number line. So we have that x can be equal to 2, so it can be 2, and it can also be all of the values less than 2. So that means all of these values down this way. So we're going to use a thick shaded in line to say all of these values up to 2. I'm going to put an arrow this way to say that it keeps going. So it goes all the values. So this number line only goes back to -3, but it would be true for all the numbers less than that, because x equal to each of those numbers satisfies this inequality. So 2 and everything less than that. It is important that you color in this line because x is a real number. If this said x was an element of z, or x is an integer, then we wouldn't have a heavy line here. We would have dots on each one of the points. If it said something like x is an element of n, the natural numbers, then we would have a dot on the 2, a dot on the 1, and no other dots, because all the natural numbers are the positive whole numbers. So 1, 2, 3, 4 off into infinity. So the only natural numbers less than or equal to 2 are 1 and 2. So having a thick, heavy colored in line is important. Part B says put a tick in the correct box in the table to show which inequality is graphed on the number line below. So we've got the values 1, 2, 3, and 4 drawn in. So we want to see which inequality is satisfied. So the first thing we notice in all of them, it says x is an element of n, so x is a natural number, and that just means that we don't have 0 and we don't have any of the numbers less than 0. So that is satisfied in all cases, so we don't have to worry about that. So next we want to look at each of the individual inequalities and see what do they say. Well, the first one says that x is less than or equal to 1. So if that were true, then we would have this dot on the 1 colored in, and we'd have all the natural numbers less than that, but there are no natural numbers less than that. So if that was true, we would just have one dot on the number 1. So it's not that one. The second one says x is greater than or equal to 1. So that would have the number 1 colored in, and the number 2 colored in, and the number 3 colored in, number 4 colored in, and all of the numbers greater than that. So that one seems to work out. Let's check the others to make sure we're not making a mistake. The next one says x is greater than 1. This is strictly greater than. It's not greater than or equal to. So if we were to graph this, we would have number 2 colored in, 3, 4, and all the bigger numbers colored in, but we would not have the number 1 colored in. So it cannot be this one. The last one says x is less than 1, which means x is all the natural numbers 0, -1, -2, but none of these are natural numbers. So if this one was the case, then none of the numbers would be colored in. So the only one that's true is x is greater than or equal to 1 for x in the natural numbers. Question 8. Grania is taking part in a training session. The graph shows the distance she traveled during the session. 4 parts of the graph are labeled A, B, C, and D. So we've got part A here, we've got part B, we've got part C, and we've got part D. Write the letters A, B, C, and D into the table to match each description with the correct part of the graph. So the first description says that Grania runs for 20 minutes. So when Grania is running, the distance she has traveled will be increasing. So we know it can't be B and it can't be D, because over this amount of time, her distance in B does not increase, it stays the same. And over this amount of time in D, her distance again does not increase, it stays the same. So we know that she's running, so it's not B and it's not D. So that leaves A and C. It says here that Grania runs for 20 minutes. In A, she's running for only 10 minutes, and in C, she's running from 15 to 35, so that is 20 minutes. So, first box, we write in the letter C. next one says Grania stops for 15 minutes. Okay, so this time we know it can't be A or C, because in both A and C, her distance is increasing, so she has not stopped. B only lasts for 5 minutes, so it's not B, and D does last for 15 minutes. So the second box is filled in with the letter D. The next one says Grania walks for 10 minutes. So that means her distance will be increasing, so it's not B and it's not D. We also know it's not C because we've already used that one, so that means it has to be A. And if we were to look at A by itself, we see that is correct. So she is moving, and she's moving for exactly 10 minutes. So the next one has to be A. This leaves only B left over for the last one. It says Grania stops for 5 minutes. So her distance will not be increasing, and it will last for exactly 5 minutes. So we write B in the last box there. Part B says Grania runs 4 kilometers in 20 minutes at a steady pace. Find her speed in kilometers per hour. So to do this, we need to know our relationship between distance, speed, and time. So you might remember this triangle. So if we're looking for speed, that will be distance over time. If we're looking for time, that will be distance over speed. And if we're looking for distance, that will be speed multiplied by time. So in this case, we're looking for speed. So we want to divide her distance by the time it took. So her speed will be equal to distance over time. Her distance is 4 kilometers. The time she runs for is 20 minutes. But we're asked for her speed in kilometers per hour. So we've got kilometers, but we don't have hours, we have minutes. So we have to convert this 20 into a number of hours. So to convert from minutes to hours, because there are 60 minutes in each hour, we want to divide by 60. So that will be equal to 4 over 1/3 of an hour. So 4 kilometers in 1/3 of an hour, because 20 divided by 60 is 1/3. So to simplify this fraction, we can multiply the top and bottom by 3. So we get 3 times 4 on the top, and 3 times 1/3 on the bottom. And that's going to be equal to 12 over 3/3, which is equal to 12 over 1, because 3 divided by 3 is 1, which is just equal to 12. So her speed is equal to 12 kilometers per hour. Question 9. Fully factorize each of the following. So the first one we're given is 7x minus 21y. And we're asked to factorize this. So there are 4 basic methods of factorization. They are the highest common factor, quadratic trinomials, factorizing by grouping, and using the difference of 2 squares. The one we want to use in this case is the highest common factor. So what that means is there is a common factor in both of these terms that we can divide by and still have whole numbers. So the common factor is 7, because this is 7 times x, and this is 21, which is 3 times 7. So this is 3 times 7 times y. So there's a 7 in both of them. So we can divide by 7 and be left with x minus 3y. So we divide this by 7 to get x minus 3y, and then to keep the value the same, we're also multiplying by 7, so the value stays the same. So we have fully factorized this by taking the highest common factor, which is 7, outside of the brackets. Part B, we're given x squared minus 25. So to factorize this, we want to use the difference of two squares. And it's something squared minus something else squared. So to do this, we see that this is x squared minus 5 squared, because 5 multiplied by 5 is equal to 25. So then to factorize it, we just say the first thing plus the second thing, and the first thing minus the second thing. So the first thing is x, the second thing is 5, and they are both being squared. We have the difference of them, so we say the first plus the second multiplied by the first minus the second. So x plus 5 in brackets and x minus 5 in brackets. Part C, we're given x squared minus x minus 6. We're told to factorize this. So x squared minus x minus 6. So in this case, we're given a quadratic trinomial. So to factorize that, the first thing we want to do is put down the brackets that we're going to fill in. Next, we want to look at this first term. This is x squared, so it can only be made by multiplying x by x. We then want to look at the sign of this last term. This is a minus, so that means the signs in these brackets must be different. So one will be a plus, and the other one will be a minus. The last thing we want to do is we want to look at the factors of 6 of this term. So those are the numbers that you can multiply together to make 6. So you can multiply 1 by 6 to make 6, or you can multiply 2 by 3 to make 6. Now you have to choose one of these pairs to put in here, so that when we add them together, they'll make this term here. So if we were to choose 1 and 6, we'd have 1 minus 6, so we'd end up with minus 5, which is not the same as minus 1x. We'd have minus 5x. If we were to choose that with the other way around, 6 and 1, we'd have 6 minus 1, so we'd have 5x, which is again not the same as minus x. If we choose 2 and 3, then we'd have 2 minus 3, which will be minus 1, which is what we're looking for. So 2 minus 3. So there's the factorization. That's equal to this. Question 10. A gym has 3 different formulas to estimate your maximum heart rate given your age. Different formulas can give different estimates. The first formula is shown in the graph below, which I have a copy of over here. Use the graph to find the maximum heart rate for someone aged 30 years and someone aged 50 years. Show your work on the graph. So, on the graph, we see that the age is on the x-axis and your heart rate, your maximum heart rate, is on the y-axis. So as you get older, your maximum heart rate decreases. So we want to find the maximum heart rate for someone aged 30. So for someone aged 30, we'll intersect with the graph here, and it will have a y value of 190. So our first answer will be 190. Next, we want the maximum heart rate for someone aged 50. So at the age of 50 corresponds to a heart rate of 170. So our second answer will be 170. So these are the answers that we put in the 2 boxes here, and we need to show these 2 lines and these 2 lines on the graph. Part B. Part of the formula that gives this graph is shown below. Fill in the missing number in the formula. So given that the maximum heart rate equals some number minus your age. So we can find this out by looking at examples on the graph. So, for instance, we know that the maximum heart rate for someone aged 20 is 200. So 200 is equal to some number minus your age, which is 20. So 200 is equal to some number x minus your age, which is 20. So when we add 20 to both sides, we get that x is equal to 220. The same works for any other point. So if we were to say pick an age of 40, that corresponds to 180. So we'd have 180 is equal to some number minus 40. 180 equals x minus 40. So adding 40 to both sides, we get again that x is equal to 220. So the missing number in the formula is 220. The second formula for finding maximum heart rate is maximum heart rate is equal to 210 minus half of your age. Use this formula to find the maximum heart rate for someone aged 60. So the formula is max heart rate is equal to 210 minus half of your age. So the age is 60 divided by 2 to get half. So that's equal to 210 minus 30, which is half of 60, which is equal to 180. So there's the answer for part C. The third formula is shown in the table on the right. The pattern in the max heart rate column is a linear pattern. So we're given that it will increase or decrease by the same amount each time. It asks us to complete the table. So in the first step, we have 190. In the next step, we have 186. So that means we've subtracted 4. So because the pattern is linear, which is important here, the pattern is linear, that means that it's going to decrease by the same amount in each successive step. So that means to get from here to here, we subtracted 4. So the next 3 steps are each going to be attained by subtracting 4 from the previous thing. So in our first box, we're going to have 186 minus 4, that's 182. Subtract 4 from that, we get 178. We subtract 4 from that, and we get 174. So those are the next 3 heart rates that correspond to the next 3 ages. Part E says using the values in the table, draw a graph on the grid below to show the maximum heart rate for all ages from 20 to 60. So I've got an empty graph here, and I want to graph these points which correspond to the ages 20, 30, 40, 50, and 60. So we just want to graph these points on our empty graph. So we're given that 20 corresponds to 190. So you have this point at 20, 190. The next point is 30, 186. So 30 and 186. The next point is 40, 182. So 40 and 182. The next point is 50 and 178. 50 and 178. And the last point is 60 and 174. 60 and 174. So we'll see that the graph is in a straight line. So that's what they meant earlier on when they said the relationship is linear. The reason we call it linear is because it produces a straight line when we graph it. So the reason we were able to reduce by the same amount each time is because we knew it was linear, and the reason it's called linear is because it produces a straight line. Question 11. Solve the equation 5x minus 10 equals 3x plus 2. 5x minus 10 is equal to 3x plus 2. So the rule when we're solving equations is that whatever we do on one side of the equals, we do on the other side of the equals. So the first thing we want to do is we want to get the x's on one side and the numbers on the other. So to do that, the first thing we're going to do is we're going to subtract 3x from this side. That'll get rid of the x's over here. And to keep the equation valid, we'll have to subtract 3x from the other side as well. So we have 5x minus 3 gives us 2 left over. So we have 2x minus 10 is equal to 2. Next, we want to bring this 10 over to the other side. So to do that, we have to add 10 to both sides, because then on this side we'll have 10 minus 10, which is 0, and on this side we'll have all the numbers. So we'll have 2x is equal to, and we add 10 to both sides, so 2 plus 10 is 12. Finally, we have 2x, but we want to see what is the value of 1x. So to go from 2 to 1, we can divide this by 2. So when we divide this side by 2, we get x, and because whatever we do on one side, we have to do on the other, we divide this side by 2 to get 6. So the solution to this equation is x is equal to 6. Part B, John says that x equals 4 is a solution of this equation. Show that John is correct. So we're given a solution. There's two different ways we could do this. One way is we could try to solve this equation, and that is much longer than the way I'm going to use, but it would be perfectly valid. The way they want us to do it is because they give us a solution, we're going to just substitute this value into this equation and show that the value makes the equation balance. So that means show that the left-hand side is equal to the right-hand side. So we're given x squared minus 2x minus 8 is equal to 0. And we're told to try x equal to 4. So we substitute 4 into this equation. We get 4 squared minus 2 times 4 minus 8 is equal to 0. 4 squared is 4 times 4, that's 16. Minus 2 times 4 is 8. Minus 8 is equal to 0. And then we have 16 minus 16, which is in fact 0. So 0 is equal to 0. Therefore, x equal to 4 is a solution. An equivalent way of doing this would be to factorize this. So we look at the first term, that's equal to x times x. We look at the sign of the last term, it's negative, so the signs in here are different. Then we look at the factors of 8, which are 1 and 8 and 2 and 4. So if we take plus 2 minus 4, then we'll factorize this. So then the solutions to this equation are x minus x plus 2 equals 0, or x minus 4 equals 0, and then we get x equals minus 2, or x equals 4. So x equals 4 is a solution. But that way is harder than just substituting 4 into the equation. So this is the way that I would advise you to do it. Part C says solve the simultaneous equations x plus y equals 11 and x minus y equals minus 5. So when we have simultaneous equations, the easiest way to do it is to add them together, because they already have a term that will cancel out, because when we add these two together, we'll have a plus y here and a minus y there, so that will cancel itself out. So everything else becomes x plus x is 2x. The y's are 0 because y minus y is 0. And then we have 11 minus 5 is equal to 6. Then we can divide both sides of this equation by 2, and we get that x is equal to 3. Finally, we can substitute this value for x back into one of our original equations. So we have x plus y is equal to 11. So 3 plus y equals 11, substituting this value for x. And then we can subtract 3 from both sides, and get that y is equal to 8. So we have now solved for x and for y. Question 12. Martin creates a pattern of numbers using the instructions in the table below. The first number is filled in. So we're given 5 as our starting number, and the instructions are we multiply it by 3, so 5 times 3 is equal to 15. We subtract 5 from our answer, so we've got 15 and subtract 5, and then our outcome in this case will be 10. We're asked to complete the table. So when we put in 6, and we're going to multiply it by 3, so 6 times 3 is equal to 18. Then we're going to subtract 5 from our answer, so 18 minus 5 is equal to 13, and then our outcome will be 13. And given the number 7, we're going to start by multiplying our number by 3, so 7 multiplied by 3 is equal to 21. Then we want to subtract 5 from that. 21 minus 5 is equal to 16. And finally, our outcome is 16. So there is the completion of the table. We want to put these terms into the given boxes. Martin picks a starting number and using the instructions gets an outcome of 1. What was the starting number that he picked? So now we're going to do the same thing, except we're going to do it backwards. So we know that our outcome is equal to 1. So in the previous step, we would have subtracted 5 from whatever our previous answer was. So something subtract 5 equals 1. So we'll have 6 minus 5 in the box above it. And to get 6, we will have to have multiplied our starting number by 3. So what number times 3 is equal to 6? The answer is 2 times 3. So the starting number has to be equal to 2. So if we start with 2, then we'll see that we'll get our final number as 1. So 2, first thing we do is we multiply it by 3 to get 6, then we subtract 5 from that to get 1. So that's our outcome. Part C. When the starting number is k, what is the outcome? Give your answer in terms of k. So this means when we put in any value of k, what formula will we get out to show our outcome? So we start with k. First step is we multiply it by 3. So we have k multiplied by 3, which will be equal to 3k. Then we want to subtract 5 from our answer. So we have 3k minus 5, and that can't be simplified down any further. So our outcome will be equal to 3k minus 5. And we're done. If this video was helpful, please go to my channel to see more fully worked solutions to Junior Certificate and Leaving Certificate mathematics exams.